Moving on to the next problem, we have one more scientific notation one, and we're going to do something very similar on this problem that we did in the last one. So if you'd like to try it on your own and pause the video to see if you get it, go ahead and do so. How many molecules of water are in a swimming pool? That's going to be a whole bunch, guys. That holds 200 cubic meters of water. Write your answer in scientific notation. Again, we do know that we have 9.98 times 10 to the 5th grams in every single cubic meter, right? Well, we also know that in every single gram, there is 3.34 times 10 to the 22 molecule. And if you see, I put that on the bottom so the grams can cancel out. And this particular pool holds 200 cubic meters, okay? And that's in one pool, essentially. You can make that over one if you wanted to. So my cubic meters cross off, so the units are gone. I'm going to get my calculator. Now I can put the tens together. I have 10 to the 5th and 10 to the 22nd. So it's going to be 10 to the 27th at the end. And the only unit I have left is molecules now. Your science teachers will be so proud of you. All right, we're going to multiply our numbers together on the top. 9.98 times 3.34 times 200. We get a pretty big number, 6,666.6. 666.6 times 10 to the 27th. This is not in proper scientific notation. I need the decimal to be behind the first non-zero number. So I have to make it we're going to head and just round it to 6.7 instead of writing all of those sixes, okay? Times 10 to the, well, let's count how many extra times we moved it. 1, 2, 3 extra times. That means it's going to be times 10 to the 30th now. And that's how many molecules of water. By the way, that's a really big number. That's how many molecules of water are in that particular pool. All right, moving on to problem 4. I know we haven't made it to 7.3 yet. This is long, and I know that. Okay, it's a good thing 7.1 was short. As we move on to problem 4, we have some stuff we got to make sure we understand. Exponents can be written as fractions. Fractional exponents, meaning exponents that are fractions, are called rational exponents because rational numbers can be fractions. Recall that 3 squared means 3 times 3, which is 9. You can write the same expression using rational exponents. 9 to the 1/2. The equation 9 to the 1/2 equals b indicates b is a positive number, and when multiplied by itself equals 9. Whoa, this is a little complicated, right? Well, if you don't mind, what we're going to do is we're going to talk about this. For now, we're going to use our calculators to get these. In Algebra 2, I'm going to teach you a very detailed way as to why these work the way that they work. Okay? But let me explain one thing. Okay, right here. And I'll explain this more in Algebra 2. A 1/2 power is the same thing as a square root. Okay? A 1/3 power is the same as a cube root. A 1/4 power is the same as a fourth root. All right, but what we're going to do now, I will explain this one right here. 81 to the 1/4. We're going to just learn how to put this in our calculators. I'm going to first watch the correct way. See how I put it in parentheses? You have to put 1/4 in parentheses. It's a 3. Okay? But if you do 81 to the 1/4 like this, if you don't use parentheses, please watch what you get. The wrong answer, because your calculator is going to do 81 to the 4th, or excuse me, 81 to the 1st and divide by 4. So I want to just use your calculator, and you're going to trust me that your answer is 3. If some of you are really like, well, why is it 3? The reason, guys, is because 3 times 3 times 3 times 3 is 81. So if you have 81 to the 1/4 power, since 4 3's make it up, 3 is your final answer. We will talk about this more in Algebra 2, and I'd be happy to explain it more to you now, but you got to trust me that you don't need it on the keystones, okay? And if you do, you can use a calculator just like I am. So you get 16 to the 1/4, this one's a 2. Look at that, I'm telling you to use your calculator, isn't it magical? 27 to the 1/3 is 3. Okay, and that one might make sense because maybe you know 3 times 3 times 3 is 27. 64 to the 1/2 is the same as 8, because it's 8 times 8. Okay, again, we'll talk about this more in Algebra 2, I promise. Alright, you can also have powers like this that you could rewrite a whole bunch of times, but guess what? I know this is crazy, I'm just going to ask you to use your calculator. I can explain this the longer way if you want me to in class, but just trust me, for right now, if you can use your calculator, you're okay. Alright, I'm going to let you use your calculator for fractional exponents. So 64 to the 3/2 power is 512. 25 is next. 25 to the 3/2 power is 125. You're like, I like this calculator stuff, right? What's next? 27 to the 2/3 power. And I will be more than happy to explain this the long way in class. Okay, but I promise you, once we get to Algebra 2, we'll explore this in detail as to why these work the way they work. But for now, you can just kind of take it for what it is. 16 to the 3/4 is 12. Okay? Alright, now we're going to get into some more power and exponent rules, alright? This is the same as it was before, except now we're using fractions. So you see everything here is multiplication. You might want to write that down. See how it's all multiplication? Watch how we do this. We put the 2 together, the 3 together, and the 5 together, because they're the coefficients. And we do the a to the 2/3. We have an a to a 1/3. We have a b to a 1/4. And we have a b to a 1/2. Just like we did it before, everybody. We do it now. 2 times 3 times 5 makes 30. Now add these exponents for the a's. 2/3 and 1/3 makes a whole, so you can put a 1 there, but it's implied. B to the 1/4 and b to the 1/2. Well, let's see. 1/4 plus 1/2 makes, oh, I know you guys love fractions. 1/4 plus 1/2 makes 3/4. Okay? You guys are going to be wonderful with fractions by the time you're done with honors algebra, I promise. If not, then get there. Alright, let's move on. Try that again. Again, this is the same we were doing before. We put 2 and 2 together. We put our c's together. What is that one? That's a c to the 3/5 and a c to the 1/5. 2 and 2 makes 4, because 2 times 2 is 4. And that becomes c to the 4/5 when you add those exponents. Part B, there's no coefficients, so we just add them up. We got 1/3. I know that's hard to see. It's 1/3 and 4/3. Well, that becomes n to the 5/3. Do not make that 1 and 2/3. Leave it as an improper reduced fraction. The next one, again, we got no coefficients, so I'm going to take my b's and add those exponents. 2/3 plus 4/9. You can get a common denominator, right? You guys are capable. The common denominator is going to be 9, so this would be like times 3 times 3, so this is really 6/9 plus 4/9 is 10/9. And the c's, so this one was for the b, the c's are 2/5 plus, what does that say? 9/10. Sorry, those are so hard to read. That is a 9/10. Common denominator is a 10, so times 2 times 2. 4 plus 9 is a 13/10. That's for the letter C. So our final answer is b to the 10/9 and c to the 13/10. See, just like we were doing before, just adding our exponents. In part D, I have a 3, and a 7. Well, that's 3 times 3 is, oh, and another 7. I missed one of my 7s, didn't I? A 3, a 7, and a 7. Well, that's 49 times 9. That's 441 with my numbers. Okay, and you can do some work over here for J. J is 2/3 and 1/6. Let me move the paper over for you. There's 2/3 and 1/6. This is for the letter J. Okay, so it's going to be times 2 times 2. 4 and 1 makes 5/6, right? That's for J. And the M is 1/4 and 3/2. This is for the M, 1/4 and 3/2. Well, 1/4 and 3/2 get a common denominator of 4, so multiply by 2. 1 and 6 is 7/4. You guys are loving these fractions, right? And that's all you have to do for that problem. All right. Now, 7/3 goes pretty fast. All right. Here's what, at the very beginning of the lesson, do you remember me telling you, this seems simple now, but you might get it confused with a rule later in the lesson? This is that rule later in the lesson, okay? What I want you to do is I want you to compare, well, we'll get there, okay? If you have x to the 5th and all of that is being raised to a second power, so you have like a power being raised to a power, I hope you know what that means is that you have x to the 5th twice. And I hope you know that means, therefore, you have x to the 10th. So how can you skip this in-between step? When it looks like this, you multiply your exponents to get how many you have at the end. Now, do not get that confused with what we learned in 7-2. What we learned in 7-2 is something like this. If you had x to the 5th and x squared, if you have the same base written twice, whereas in this problem the base was only written once and it was being raised to a power to a power. Okay, do not get that confused with the problem when the base is being written twice. In 7-2, you learned how to add exponents. In 7-3, you learned how to multiply exponents. Make sure you understand how the different format is set up. You can read what they wrote, but it's pretty much what I just said. Okay, problem 1. What is the simplified form of n to the 4th to the 7th? Because it's written like this, it's a power to a power, I multiply 4 times 7 and I get n to the 28th. Don't get that confused with what you would have done in 7-2. In 7-2, the problem would have looked like this. It would have said n to the 4th, n to the 7th. That's a way different problem. In 7-2, you would have got n to the 11th. But when it looks like this, when it's a power to a power, you multiply them. Part B, you're going to take 2/3 and multiply it by 1/2 when it looks like this. Well, that's going to be 1/3 when you multiply because the 2's cancel out. So I get x to the 1/3. Don't get that confused with 7-2. In 7-2, you would not have multiplied them, you would have added them. All right, maybe you want to try these and then turn the video on to see how you did. The answer to part A is p to the 20th because you multiply. Answer to part B is p to the 20th because you multiply. The answer to part C is p to the 1/8 because you multiply 1/2 and 1/4. And in part D, the answer is also p to the 1/8 because you multiply 1/4 by 1/2. So here's the question. Is the reverse, if you have like a 5 and a 2 and then a 2 and a 5, is it true for all integers for m and n? The answer is definitely yes, because multiplication can be reversed. In other words, multiplication is commutative. Do you remember that? That word from way back in chapter 1 with Mr. Lankitz? Multiplication is commutative. In other words, it can be flip-flopped. All right, let's try problem 2. And notice what I put here, a little bit of adding and multiplying. When do you add? When do you multiply? So I'm hoping to answer some questions here. Okay, the first thing we need to take care of is what I put in a box, because this is a power to a power. If you ever have a power to a power, you gotta take care of that first. So 5/2 times -2 is what we learned right now. That equals a -5, right? Because the 2's cancel out. So really this problem could be y to the third and y to the negative fifth, because I simplified this box to y to the negative fifth. Then you apply, so this was your rules from section 7.3 because that's the format it took. Now look at this. We use your rules from 7.2 because the base is written twice. We add our exponents, so you get y to the negative 2. Oh, and you're going to love this. Do you remember your rules from 7.1? You're never allowed to have a negative exponent. So that's 1 over y squared. See how you need to really know all of your rules from your different sections and be able to apply them when they come along. All right, let's do got it, number 2a. You might not want to pause the video on this one. You might want to watch it out. You're going to always take care of the power to the power first. So this is x to the negative 24 because you multiply them. This came from section 7.3. And so we get x squared and x to the negative 24th after we did that. Now we use our rules from 7.2 and we add our exponents. We get negative 22. And then we use our rules from 7-1, and remember you're never allowed in simplified form to have a negative exponent, which means it goes on the bottom. Alright, let's do b. You take care of the parentheses first with the x power to the power. 5 over 3 times 3 is 5. So this becomes, from 7-3, you just learned this, w to the negative 2 and w to the fifth, because this is the w to the negative 2 and that whole box is w to the fifth. From 7-2 you've learned to add them, w to the third, and you don't need to apply your rules from 7.1 because you have no negative or zero exponents to deal with. Part C. Take care of the power to the power first. So negative 5 times negative 1/2 is a positive 5 over 2. So the whole box, we use rules from 7.3, the whole box becomes s to the 5 over 2 with the s to the 3 over 2. Okay? Then from 7.2, we know we need to add, right? We need to add our exponents because they're the same base. Same base gets added. That becomes s to the 8 over 2. And then we should definitely reduce that to s to the 4th. And we don't need to apply any rules from 7.1 because there are no negative exponents to deal with.